Hello my dear students, welcome back to EZEE Notes. Today we'll be continuing the chapter Machines, in which we'll be studying part B, that is nothing but about pulleys. What is a pulley? See, a pulley is a circular disc with a grooved rim. This type, you might have seen pulley, right? So there is a circular disc and there is a grooved rim present here. Okay, a string or a rope passes through the groove. This is nothing but a string, right? This yellowed color. Next, it rotates about a fixed axial fixed to frame. This is an axial. Okay, so about this axis it will be rotating. If this is an axis, it will be rotating like this, in this way, right? Used to change the direction of force or reduce effort. It is used to change the direction of force. See, if you are taking up something like this, if you use pulley, we can take it in this way, take it up, right? By changing the direction of effort and by less effort compared to this one with heavy effort. Okay. Next, a single pulley works in two ways. How? Fixed pulley, that is nothing but frame is fixed. This frame will be fixed. This won't be moving. Okay. And movable pulley, the frame moves. So let us see one by one. Single fixed pulley. A pulley which has its own axis of rotation fixed in position is called a fixed pulley. Okay. Axis of rotation is fixed. When the string is pulled, it is friction. It is a friction between the string and the surface of the rim of the pulley which rotates the pulley. When the string is being pulled or pushed, what happens? The rim will also get rotated, right? So there is a friction. The pulley will also get rotated. The disc. So friction between rim and rim and the string will get the pulley rotated. Okay. In actual practice, there is always some friction at the axial or in the pulley bearings. So the effort needed is little more than the load to be lifted. Okay. The actual load might be of 100 Newton. The effort will be something 110, 120, a little more. Okay. A single fixed pulley has its axial fixed to a rigid support. Okay. So let us see how it will be. First thing, it will be fixed like this. This is an axle and there will be a pulley like this, right? So there will be a string, right? This is a string. Here there will be some load attached. The load will be acting downwards. And here we will apply some effort, right? So we are applying some effort here. So you must know that in a single string or a single rope, tension will be same at every point. And tension is away from the fixed point. Okay. So if I consider this as a fixed point, this is a fixed point, right? So tension will be away in this way. And here this is as a fixed point, the tension will be away from the point. So from here we can see that effort, if you see only this much, we can say that effort is nothing but T. But also if you see here, load is also equal to T. So what will be its mechanical advantage, velocity ratio and efficiency? So let us see what is mechanical advantage. Mechanical advantage is load upon effort. So load is T and effort is also T. So mechanical advantage will be equal to 1. Okay, done. The mechanical advantage of single fixed pulley is how much? 1. Now what is VR? Velocity ratio. What do you mean by velocity ratio? We have learned, right? Velocity ratio is nothing but distance of effort, distance moved by the effort divided by distance moved by the load. See, if there is same tension applied, if I am applying the same tension, same force I am applying, if this is being pulled with T, this is also being pulled up with T, right? By the same force. I am applying the same force here. So this will also be gaining the same force, right? So if this gets downward by distance D, this will get upward by distance D, because there is a same force for both of them. If load and effort is same, then the distance moved by them will also be same. Okay. So this will also be D upon D, that is nothing but 1. So velocity ratio will also be equal to 1. Lastly, efficiency is nothing but mechanical advantage upon velocity ratio. So what is mechanical advantage? Mechanical advantage is also 1. Velocity ratio is also 1. Efficiency will also be 1. That is nothing but efficiency is 100%. But this is an ideal ideal fixed pulley. Ideal means we assume that there is no friction here. Okay, if there was friction, this effort would be more than the load, and the mechanical advantage would not be 1, it would be less than 1. Okay, remember that. If it is we are talking about only ideal. Okay, every time we'll talk about only ideal. If you're talking about friction, we'll mention there. Okay, assume that there is a friction between the axle and the rope, rim and the rope. Okay, next, purpose of fixed pulley. What is the purpose? A pulley which has its axis of rotation fixed in the position is called fixed pulley. We know that when the string is pulled, it is the friction between. We also know this point, right? Yeah. Next, in actual practice, there is always some friction. In actual practice, there are yeah, we have learned this at the axle or in the pulley bearing. So the effort needed is little more. Yeah. A single fixed pulley has its axis. See, yeah. The editor might have copied the same points which we have learned. Okay, purpose of fixed pulley is what? We can easily take up the load in a different direction by changing the direction. Okay, as the mechanical advantage is 1 and efficiency is also 100%, it becomes easier to pull up. Okay, that are the purpose of fixed pulley. Next, single movable pulley. A pulley whose axis of rotation is movable. Axis of rotation will also be movable. How is that? Perceive it. That is not fixed in position is called single movable pulley. Load is attached to the axle of the pulley. Acts as a force multiplier. In ideal case, there is no friction. How will it be? Let us see here. Okay, this is an axle. For this, there will be load attached like this. This will be like this. See what happens. As soon as I give the effort, this load and this pulley comes up. So this is movable pulley, not fixed. It is not fixed about this axis. Okay, it can move up. Right? You can imagine. See, if I am pulling this up, this will also get stretched and this will also get. It means that the string here will be less this side. So it will also get pulled up, right? So this pulley and this load, they also come up. Okay. Now the efforts and load. This is the effort. Here is the effort applied at this point. We are applying the effort. Now tension is here, right? Tension T. So about this fixed point as well, there will be tension T. Now here also there is tension T. And the load is acting downward. If we see for only this part, we can say that effort is equal to tension. But load is balancing both the tension. See, both the strings. Load is balancing the two strings. Effort is only balancing this first string. I am applying the effort on the first string itself. Only one string. Okay. But load is balancing these two tensions as well, right? The two sides of the tensions. So we can say that load is nothing but 2T. It is balancing these both of the tensions. Now what will be mechanical advantage? Mechanical advantage will be load upon effort. So mechanical advantage will be load is 2T upon T. So mechanical advantage will be equal to 2. Sorry. Next is velocity ratio, right? What will be velocity ratio? Velocity ratio is distance moved by effort divided by distance moved by load. See, there is no same tension. Load and effort are not same. Okay, if the force is not same, but work will be same here, right? Input work will be equal to output work. If the work is being done same on both the cases, because we are assuming that there is no friction, so work will be same, input and output will be same, efficiency will be 100%. Okay, so now what happens? If I am moving it by T tension, this is moving by 2T. So more the force, work is nothing but force into displacement, right? So if force is more, displacement will be less. If force is less, displacement will be more to keep the work constant. If this is T, and let us consider displacement of effort as D, and if this is 2T, displacement of load will be D by 2, right? Half of that. So 2 and 2 gets cancelled out. So T into, see, work input will be effort into, effort is how much? T, right? Into D. Work output will be 2T into, I'm saying it will be D by 2, because D and 2 and 2 gets cancelled. It will again be T into D. So work should be same, right? So we can say that if the distance moved by the effort is D, the distance moved by the load will be D by 2. Remember that, because there are 2T, two tensions are being balanced by load, so it will only go up by distance D by 2, because this pulley will also be pulled, right? This will move by D by 2 and this will also be moved by D by 2. Total displacement is D only, but this and this will move in a different way. Okay, so here D and D will get cancelled out. So VR will be equal to denominator becomes numerator, that is nothing but 2. So efficiency will be mechanical advantage upon VR, that is nothing but 2 upon 2, that is 1, which means that it is 100%. Understood? Easy? Okay. Next. In actual case, friction plus pulley weight is present. In actual case, there is a friction and pulley weight is also present, right? Pulley will have some weight, right? This will have some weight, obviously. So at that time, mechanical advantage will be less than 2, because load will be not equal to 2T. It will be less than 2T. Okay, that's what. But VR will be equal to 2, because it will move half a distance only. Remember. Okay, because it is balancing two tensions. Next, efficiency will be less than 100%, because mechanical advantage is less than 2. How can we change the direction of effort? Because to pull like this is a bit tougher. So what we do is we attach a single fixed pulley and pass the string from here. So we can apply the effort here and this can come up like this. Easy. See, a movable pulley alone needs an upward effort. We should apply the effort upwards, but a fixed pulley is added to apply the effort downward. So mechanical advantage VR and will all remain same. After applying this also, see here, effort is being applied here, right? So tension will be here. So effort will be equal to tension, but load is balancing only these two tensions. So load will also be equal to 2T only. So mechanical advantage and VR will remain same. VR, however, is same only. It will be 2. Next, difference. What is the difference? Single fixed pulley and single movable pulley. Let us see. It is a fixed to a rigid support. It is not fixed to a rigid support. Its mechanical advantage is 1. Its mechanical advantage is 2. Its velocity ratio is 1. Here velocity ratio is 2. Okay. The weight of pulley itself does not affect its mechanical advantage. Here weight of pulley can't affect the mechanical advantage. Why? Because only tension is acting. In the string, the load is attached. In the fixed pulley, the load is attached to the string, not pulley. So weight of pulley won't affect the mechanical advantage. But here the weight of pulley can affect the mechanical advantage and it reduces the mechanical advantage. Next, it is used to change the direction of effort. It is used as a force multiplier. The load moves in a direction opposite to that of effort. If you are applying effort here, the load will move up. But in single movable pulley, if you are applying force effort here, the load will also move upward. The load move in the direction of effort. Next, the axis of rotation does not move in space. The axis of rotation also moves. Here axis of rotation will be fixed to the axle, but here it won't be fixed. As soon as we apply the effort, it also moves up and down. Combination of pulleys. How can we combine pulleys? Used when heavy loads are to be lifted. If you have to lift too much heavy load, we can use. Why? Required when mechanical advantage is greater than 2. If it is equal to 2 or less than 2, we can use single fixed pulley or movable pulley, right? A single movable pulley is not sufficient. Methods for combination. There are two methods of combination. One is one fixed pulley plus several movable pulleys. The other is block and tackle system. Upper block is fixed and lower block will be movable. So let us see how it will be. Here, one fixed pulley and other movable pulleys. So this D will be fixed. This is fixed. These three will be moving. Why is it fixed? We can see that this is directly connected to rigid support. These are not connected to rigid support, so they can move. Okay. Multiple movable pulleys connected using separate strings. Okay. Tension is same in one string. See here. If string is same, tension will be same. This whole string is same from here to here, so tension is same, T3. This string is same, so tension is T2. This string is also same, so tension is T1. So tension will be same only in same string, not different strings. Tension differs in other strings. Okay. Maximum tension occurs in the string attached to the load of pulley. Load pulley. How? Let us see. This is an axle. There is a fixed pulley here. Okay. Here we are applying the effort. Okay. Here there will be another pulley. This will be connected to another rope. See? Another rope. It will be connected to another rope like this. So here there is another pulley. Right? Somewhat in this will be connected to another pulley like this, and here there will be last pulley which will be connected to load. Okay, let us see. First thing, here the tension is T. Let us assume it is how much? Here the tension is how much? T. Okay. In the same string here it will also be T and T. But this T and T will be balanced by this string. There is nothing but 2T. Right? These two is being balanced by only a single string. That is nothing but 2T. So here if it is 2T, this will also be 2T. Now this is balancing by this one. It will become 4T, not 3T. It will become 4T. So this will also be 4T. So now load is balancing 4T plus 4T, 8T. So we can say that effort is nothing but T. But load is 8 times of T. See here? See here. Understand? In the same string, tension will be same. So these two tensions are being balanced by only this string. There is nothing but. So it will balance 2T. If this is 2T, this tension in the same string will be 2T. These 2T and 2T is balancing by the third string. In the third string, the tension is 40. And 40 and 40 is being balanced by load. So load is 8T. We can write 8 as 2 cube into T. 8 2 cube into T. Generally, what we can write? Generally, effort is equal to T and load is equal to 2 to the power n T. 2 to the power n T, where n is the number of movable pulleys. Number of movable pulleys. See, 1, 2 and 3. If 3 movable pulleys are there, the power will be 3. If there are 4, the power will be 4. If there are 5, the power will be 5. In that way. Okay. So we got effort and load. So we can find mechanical advantage. So let us see what will be the mechanical advantage. Mechanical advantage will be load upon effort. Load was 2 to the power nt and effort is t. So t and t gets cancelled out. Mechanical advantage will be 2 to the power n. So it is greater than 2, right? Next, what will be velocity ratio? See, understanding. If this is being pulled by t, is being pulled by 2t, right? So if this moves the distance d, this will also move up by distance d. Sorry, d by 2, right? Because 2t. Understood? Same as single movable pulley here. You have understood, right? Yeah. Alright, sorry. In this, if this moves by t, if these two are being balanced by load, so load will move by d by 2. If this is moving d, load will move by d by 2, half of that. So here in the same way, if this moves down by d, it moves up by d by 2. If this is moving up by d by 2, this will move by d by half of that, that is nothing but d by 4. If this moves by d by 4, this will move by d by how much? Half of that's 8. So load will move up by d by 8. So we can say that VR is distance of effort by distance of load. So if it is d, it will be d by 2 to the power n. Understood? D by 8 means we can write this d by 2 cube. So in the same way we can write what? D, if dE is d, dl will be d by 2 to the power n. Same formula. Okay, in this it will be multiplied tension, it will be divided. So d and d gets cancelled out, velocity ratio is also 2 to the power n. If both are same, efficiency will be 100%. We know that. Understood? Sorry. Next, using several pulleys in 2 blocks, that is nothing but block and tackle system. Let us see what is block tackle system. It consists of 2 pulley blocks. Okay, upper block is fixed. Upper block is fixed. Lower blocks are movable. It is used to lift very heavy loads. Okay, arrangement. How is the arrangement? How is the pulleys are arranged here? Number of pulleys in lower block should be equal to or 1 less than the upper block. See here, in upper block there are 3 pulleys here. Here there are only 2 pulleys. Here 2 and 2. It can be equal to upper or 1 less than upper. Okay. Always downward application of effort. Effort is always applied downwards. So let us see its mechanical advantage. Okay, string and forces here. One strong light inextricable string passes over all the pulleys. So tension will be same in all the pulleys. It means that only one string is passed through all the pulleys. The load attached to the lower block always. Effort applied to the free end always. Tension T is same throughout the string. Okay. Example: 5 pulleys, string end attached to the lower block. See, string's end will be here, it is attached to the lower block. Okay. If there are 4 pulleys, string end attached to the upper block, here it will be attached to the upper block. Remember, if odd, lower block, even upper block. Simple. Okay, let's do it here. Okay. How many pulleys? Let us make about 5 and 4. Okay. Let's make 5 and 4. 1. So this must be 2 and 3. Okay. 3 block upwards. 1 and 2 downwards. Just a minute. Yeah. It must also come downward, right? Because to get attached like this. 1 and 2. And here there is a load attached. See, is it right now? Yes. Now we have to draw the strings. Let us draw the strings now. It is passing from here, right? Here we are applying the effort to the free end. So it goes from here to here, then here to here, then from here to here, then from here to here, then lastly it will be connected to lower one. Understood? Similarly for 4. See, 1 and 2. It should be in the middle. Understood? Understand that? 1 into load attached. So now if I pass strings from here, this will be string and here effort will be applied. So this will pass through this and this and this and it will be attached to here. Now let us calculate the tensions. This is effort, so this will be tension T. So we can say that effort is equal to T. But what about load? If this is tension T, in this string will also be tension T. This string will also contain tension T. This string will also contain T. This will also contain T, and this will also contain T, because that is the same string. So all these 5 strings which are being balanced by the load contains how much tension? T, 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 and T. So we can say that from here 5 tensions are being balanced by one load. So load will be equal to 5T. Simple. But in here, if we say that this is tension T, we can say that effort is equal to tension. See here, T, 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 and T, T, right? So 4 tensions are being balanced by load. We can say that load is equal to 4T. Generalized way, we can write that if effort is equal to T, load will be equal to NT, where N is number of pulleys, not movable pulleys. It will be number of pulleys. If there are 5 pulleys, it will be 5T. If there are 4 pulleys, it will be 4T. Understood? In the same way, if it goes distance D down, it will go distance D by 5 up, because 5 strings are being balanced. Here, if it goes by distance D down, it will go up by distance D by 4. We can say that distance of effort is D, then distance of load will be D by N. D by N. N is the number of pulleys. Simple. Okay. Now we will calculate the mechanical advantage. What is mechanical advantage? Load upon effort. So load is NT, effort is T. T gets cancelled out, so mechanical advantage will be equal to N. Velocity ratio will be distance of effort upon distance of load. So it will be D upon D by N. So D gets cancelled out, so velocity ratio will also be equal to, and therefore we can say that efficiency is 100%. Understood? Easy? Yeah. Next. Effect of weight of pulleys on mechanical advantage, velocity ratio, and efficiency. How about the weight? Consider a system of n pulleys. Let W be the weight of total weight of lower block along with the pulleys. Okay. So what is W? W is weight of pulley. W be the total weight of the lower block along with the pulleys in it. Okay. W is the weight of the pulleys. Okay. Now we can say that. What is load? What was load here? Load was NT, right? Now load will be, say simple, upside it was n times of t, that is nothing but 5t. 5t is your upside. Down it was only load, so we can say that load is equal to nt. But now weight will always act downward, so weight is also acting downward. From here we can say that load is nothing, load plus w, load plus w is nothing but nt, right? These two are being balanced by these 5 strings. Okay, from here we can say that load is equal to nt minus w, nt minus w. So can we calculate mechanical advantage? Yeah, we can calculate mechanical advantage. Let us shift this thing. Okay, see, we'll calculate mechanical advantage here. Mechanical advantage will be equal to load upon effort. So load is W minus NT upon effort is T. Simple. This is nothing but mechanical advantage. If I take it as an LCM, it will be W by T minus N. Right? W minus NT or NT minus W. Just a minute. NT minus W. Sorry. It is nothing but NT minus W divided by T. So it will be N minus W by T. This is nothing but mechanical advantage. So what will be velocity ratio? Velocity ratio will be N only, because it doesn't change, right? Effect of pulley, anything. If there is weight as well, 5 strings are only taking it up, so it will come up by divided by 5. Okay, divided by N. So velocity ratio will be N. So efficiency will be N minus W by T divided by N. So if we divide this, what happens? I can write it as NT minus W by NT. So it will be NT by NT is 1 minus W by NT. 1 minus W by NT, because N by N will be 1. This will be 1 minus W by NT. Yeah, correct. This will be our efficiency. It means that, see, 1 minus something. 1 minus something means it is less than 1. Less than 100%. If weight of pulleys are included. If weight of pulleys are not included, it will be 100%. Understood? So let's head towards some questions. A woman draws water from well using a fixed pulley. Which pulley? Single fixed pulley. The mass of bucket and water together is 6 kg. So load will be how much? 60 Newton, right? 6 kg means 6 into G. So load will be 60 Newton, right? That is nothing but the force applied to the woman is 70 Newton. Sorry, by the woman. By the woman, effort. Effort is how much? 70 Newton. Calculate the mechanical advantage. Take G as 10. So we have taken it as 10. So mechanical advantage is equal to load upon effort. Load is 60 upon 70. So 6 upon 7. It will be less than 1 something. So calculate it. Okay. Next. A single fixed pulley is used to lift 20 kg object. Okay. It is used to lift 20 kg object. Calculate the effort required assuming there is no friction. Yeah. We know that mechanical advantage is equal to 1. So load is equal to effort. We need effort. So effort is nothing but load is 20 into 10. That is nothing but 200 Newton. That's it. इसी वजह से ये याद रखना है. You need to remember this. Mechanical advantage is 1 for single fixed pulley. Next. Meera chose to use a block and tackle system of 6 pulleys. How many? 6. So 3 up, 3 down. Instead of a single movable pulley to lift heavy load. Okay, अच्छी बात है. What is the advantage of using the block and tackle system over a single movable pulley? What will be the advantage? The advantage will be that mechanical advantage is how much? Same thing. Advantage is how much? 6. But in single movable pulley it is 2. So by applying little effort, see, understand, if we are applying the effort and taking up only 10 Newton in single movable, single fixed pulley, so how much weight I can take in single movable pulley? 20 Newton, right? Because mechanical advantage is 2 times of that. Okay. In block and tackle, into how many? 6 are there. Into 6. It means that instead of 10 Newton, I can take by the same effort, I can lift the weight of 16 Newton. So advantage will be that we can lift heavy load with less effort. Why should she connect a greater number of pulleys in the upper fixed block? She is not connecting, right? 6 pulleys. So 3 upper, 3 niche, right? So if there are odd number of pulleys, why she should connect? Why? Because for greater balance. Okay, remember. Next. A block and tackle system of pulleys have velocity ratio 4. How much is the velocity ratio? 4. Okay. Draw a neat label diagram of the system indicating clearly the direction of the load and the effort. If the velocity ratio is 4, it means that there are how many pulleys? 4 pulleys. 2 up and 2 down. So we can consider this one, right? 2 up and 2 down. Okay. Now what he is asking? What is the value of mechanical advantage of the given pulley system if it is an ideal system? If it is ideal pulley system, mechanical advantage will also be 4 because efficiency will be 100%. Simple. And the diagram, we have done it before. Next. A boy uses a single fixed pulley to lift a load of 50 kgf. So load is how much? 50 kgf. That means 500 Newton into 10. because 1 kgf is 9.8. Approximately we are considering it as 10. To some height, another boy uses a single movable pulley. First is single fixed pulley, next is single movable pulley. To lift the same load to the same height, compare the effort by them. We know that mechanical advantage of fixed pulley is 1 and mechanical advantage of movable pulley is 2. If the load is same, what is the formula for mechanical advantage? We know that mechanical advantage is load upon effort. If load is same, mechanical advantage is inversely proportional to effort. So we can say that effort being applied by fixed pulley will be greater than effort applied on the fixed pulley will be greater than effort applied on the movable pulley. Why? Because mechanical advantage, if the mechanical advantage is more, effort will be less. So effort on mechanical advantage, movable pulley will be less compared to effort on fixed pulley. From the diagram given below, answer the questions. Okay. What kind of pulleys are A and B? So A is single movable pulley and B is single fixed pulley. State the purpose of pulley B. So you have to comment. So question number 6, sub question B is so and so answer. Okay, let's see who will comment. Next, what effort has to be applied at C just to raise the load of 20 kgf? How much effort should I apply at C? Let us see. Mechanical advantage will be load upon effort. So mechanical advantage is 2. Load is 20 kgf. So what will be effort? Effort will be 2 ones are 2, 2 tens are 20. 10 kgf effort should be applied. By applying 10 kgf effort, we can move 20 kgf load. Neglect the weight of pulley A and friction. We have neglected that. A system of 5 pulleys, okay, is arranged to form a block tackle setup shown on a diagram. Show on a diagram. We should draw the diagram. Okay. The manner in which the string is around over the system of pulley also indicate the points where the load is suspended and where the effort is applied. And effort applies to this system is used to raise the load by 60 centimeters. It's simple. Distance of effort. Distance of load is how much? 60 centimeter. Find the value of distance over which the effort has moved. So distance of effort we need. We know that velocity ratio is nothing but distance of effort upon distance of load. Velocity ratio is nothing but how much? Number of pulleys. 5 is equal to distance of effort upon distance of load is 60. So distance moved by the effort will be 6 5s are 300 centimeter. And the diagram for this we have drawn before. If you need me to draw again, it will be something like this: 1, 2, and 3 pulleys. Okay, 1 and 2. Here there will be load connected to this, and these are the strings passing through this. Okay, so next, a pulley system with VR is equal to 4 is used to lift a load of 175 kgf. Load is how much? 1750 Newton or 175 kgf. To a vertical height of 15 meter. Oh, distance moved by the load is 15 meter. The effort required is 50 kgf. Okay, effort is also given 50 kgf. It is nothing but 500 Newton. Okay, in the downward direction, calculate. First is distance moved by the effort. Distance moved by effort is distance moved by load into velocity ratio, because velocity ratio is distance of effort by distance of load, right? So distance moved by effort is, load is 15, velocity ratio is 4, that is nothing but 60 meter. So distance moved by the effort will be 60 meter. Okay, work done by the effort. Work done by the effort will be equal to effort into distance moved by effort. So work done by the effort will be equal to, effort is how much? 50 kgf. That is nothing but 500 Newton into, this will be 60. 5 6 are 30 triple zeros Newton. Sorry, joule. Right, 30,000 joule. That is means that 30 kilojoule. Okay, mechanical advantage of the pulley system. Okay, let us calculate mechanical advantage is equal to load upon effort. Load was 175 kgf, effort was 50 kgf, right? Yep, 175 and 50. 50 ones are 50, 50 53s are 150, right? Okay, point. So it will be 250 remaining. So 55s are 250. So mechanical advantage is nothing but 3.5. Okay. Next, efficiency of the pulley system. So what will be efficiency? Efficiency is mechanical advantage upon velocity ratio. Mechanical advantage is 3.5, velocity ratio is 4. So it means that it will be 7 by 8. 5 sevens are 35, 5 eights are 40. Yeah, 7 by 8, so 0. So it will be 0.8, then 60 remaining, right? So 0.87. Okay, how much will be the efficiency? 87 point, I think 5. Check it out. Okay, 0.875, I think. Next, draw a diagram to show a block and tackle pulley system having velocity ratio of 3, marking the direction of 3. 3 means 2 in the upper and 1 will be in the lower, and here will be load applied. Okay, so these are the strings. Effort here, this will go from here, then here. Okay, in this way. Tensions T, T, T and T. The pulley system drawn lifts a load of 150 Newton. Load is how much? 150 Newton. When the effort is 60 Newton. Effort is 60 Newton. Okay, find its mechanical advantage. So let us find mechanical advantage. It will be load upon effort. 150 upon 60. 0, 0 gets cancelled out. So it will be 6 2s are 12, 6 5s are 30. Okay, 2.5. Is the above pulley system an ideal machine or not? If there are 3 pulleys, mechanical advantage should be 3. Here the mechanical advantage we are getting is 2.5. So it is not an ideal machine. Why? Because some of the energy is being wasted, right, due to friction. Okay, remember. The adjacent figure shows a fixed pulley used by a boy to lift a load of 400 Newton. Okay, so a vertical height of 5 meters in 10 seconds. The effort applied by the boy on the other end is 480 Newton. Load is less, effort is more. So mechanical advantage will be less than 1. What is the velocity ratio of the pulley? Okay, velocity ratio will be simple, right? Velocity ratio is 1. Because the same distance will be moved up. What is the mechanical advantage? Mechanical advantage will be 400 upon 480. 40 upon 48. Calculate it. Okay. What is the efficiency? You can also calculate this by mechanical advantage upon velocity ratio. Okay. You have to do this as a homework. I'll give the hint just. Why is the efficiency of the pulley system not 100? Because mechanical advantage is less than 100, right? So efficiency will also be not 100, because what? It might not be a ideal pulley. That's why we are applying more effort compared to load. What is the energy gained by the load in 10 seconds? Energy will be nothing but load into distance of load. So load is 400, distance of load is 5 meters. 4 5 are 22,000 joule. How much power was developed by the boy raising the load? Power will be equal to energy into time t. This one, this energy we have to use here. Into time is 10 seconds. The boy has to apply the effort which is greater than the load he is lifting. What is the justification for using the pulley? What we can say? We can say that this is not an ideal pulley and there is a friction between the rim of the pulley and the rope he is on which he is applying the effort. Figure shows a system of 4 pulleys. Okay, the upper 2 pulleys are fixed and the lower 2 are movable. Okay, draw a string around the pulleys. Also show the point. Same, we have to complete the diagram. Let us complete the diagram. This is a string passing from here. Effort, tension, 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 and this is load. What is the velocity ratio of the system? Velocity ratio will be 4, right? Simple. How many number of pulleys? That is nothing but number of velocity. What is same as the velocity ratio? How are the load and effort of the pulley system related? So load is nothing but 4t and effort is nothing but t. So we can say that load is equal to 4 times of E. Instead of t, I substituted with E. What assumption do you make in not arriving at your answer in part C? We have arrived at our answer, right? Figure shows a block and tackle system of the pulley used to lift a load. Okay. How many strands of the tackle are supporting the load? How many? 1, 2, 3, and 4. 4 are supporting load. Draw arrows to respond to tension in each strand. Up 1, 2, 3, and 4. What is the mechanical advantage of the system? It will be 4. Whenever they don't say, as it's not an ideal pulley, we can consider the number of same as number of pulleys. Okay. When load is pulled up by a distance of 1 meter, how far the effort moves? If load is pulled by 1 meter, effort must be pulled by 4 meter, right? Because there are 4 pulleys into 4. How much effort is needed to lift a load of 100 Newton? So load is equal to 4 times of effort, right? So effort will be equal to 100 upon 4. That is nothing but only 25 Newton is required to lift a load of 100 Newton. Understood? I hope you have understood each and every question and concept as well. So we'll end this chapter with this question. We'll meet in the next chapter, that is nothing but refraction through plane surfaces. Till then, keep practicing, keep supporting, and download these notes. Bye bye.